There it goes. Can everyone hear me? Perfect. All right. Welcome to United Astronomy Clubs of New Jersey. We are on site. We have a bit of an unexpected rainstorm. It was not originally in the forecast when we decided to have it here, our presentation here tonight, but we thank everyone who has come out to join us here on site. And we also want to thank everyone who is joining us online through our online chat rooms. Right. To get you started, for those people online, uh, or and also here, do check us out on our website, uacnj.org. That's where you'll find information on our club, all our member clubs, as well as all our presentations that we have available, as well as if we're going to be doing any special events. You can also check us out on our socials, Facebook, Instagram, Twitter, and our Discord channel. They're great ways to keep in touch with us. Do like and subscribe on the YouTube channel if you find you do like our programs. Uh, we are a nonprofit, so everything you see here from our volunteers who donate their time and efforts to keep everything running, to you guys who have kept us able to pay our bills and upgrade the stream and take care of our buildings on site. We also thank you for that. So, for our people here, if you do need to use the restroom, we have the porta potty to my right, your left. We do have a little gift shop and a museum area in off the door in the house to my left, your right. All the proceeds do go to keeping our site maintained as well as offering improvements. So, with that, we're going to get into tonight's presentation, which is about earning your astronomy scouting badge with Sean. Sean was born 15 minutes before Apollo 11 lifted off to take man to land on the moon. Sean came with a love of space and science built in. He also has an uncanny way of bringing clouds to Ginny Jump, and this time he's even upped his game and brought the rain too. So now he loves sharing his love of space and science with his son Sebastian, and he's here to offer the same to us tonight. Is it on?
I pressed the button. There it is. All right. So thank you, everyone, for coming out tonight. I apologize for the rain. It's my one time up here this year, and I figured it had to be special. Tonight, we were expecting when the schedule was first made that we were going to have several Boy Scout troops up here camping in the forest. They may or may not be there, but I don't see them here tonight. But that's okay, because we're going to record this and we're going to have it online for any Boy Scout troop that wants to use this for helping their members get their astronomy merit badge. So before we get started, the information here is current as of today. So if the Boy Scouts change stuff up, that's on them, not on me. I did use their resources quite heavily. They have a worksheet that is online. It's the second line here. I do follow the worksheet pretty closely, but not completely closely, because there's some stuff that I had to edit out to not keep this like a 2-hour presentation. Wanted to keep it down to about 45 minutes. The software that I use is called Stellarium. It lets you look at the sky, how it would look anytime, any place on the Earth. You can go way back in time. You can go forward in time. It's really great stuff. It's free that you can download it. And there's some other resources you can use. Heavens Above and Constellation Guide are 2 free sites that will have information that will help you get your merit badge. And there's also the NASA sites and Sky and Telescope, space.com, some really, really great resources. So some of the things we're going to go over tonight. The hazards, this is the first part of the presentation of their requirements, is the hazards of astronomy activities. There are some. Proper clothing and preparation, safe observation, light pollution, astronomical tools and instruments. Stars and constellations, where we start looking at what the sky would look like tonight. And then the visible planets, the moon, the sun, and some careers that are available in astronomy. One of the things that's not in here tonight that the worksheet goes over is first aid. You got to know that for the merit badge. I trust that your troops will be able to cover that, have a first aid kit available, know where you're located, have cell service. That's stuff that you'll be able to do with your troops and not really need this presentation for. So the hazards, most likely hazards, is you're going to be navigating in the dark. And one of the ways to get around that is to come up and visit the area during the daytime, see what kind of hazards you have. We have out here guy wires, curbs, exposed stones, a nice little cliff if you walk a little bit too far. That first step is a doozy. The fall doesn't hurt. The sudden stop at the bottom does. You'll see later on some of our volunteers will be having red light flashlights. They use red light to keep your night vision intact and still let you see at least a little bit. We have the red light on the porta potty. That'll help you see it in the dark. Cold exposure and hypothermia, not too much of a issue tonight, but if you're out in the winter, you definitely want to keep track of what the weather's going to be. You're going to dress in layers. Hopefully it won't be too cold. We've had people up here when it's like stupid cold. Luckily the house is heated so they can come in. If you're a member of one of the clubs, you can come up here on a non-private or on a non-public night, and you'll have access to the building and you can keep warm a little bit. One of the other things that's been popular lately too is remote controlled telescopes, where you can get a telescope and get an observatory and put it up someplace where there's nice dark sky all the time. I know New Mexico has a couple of those. And then you just log in from your computer and remote control everything. And then you can stay nice and warm. So you definitely want to dress appropriately even during the summer. It will get a little bit chilly tonight, especially with the wetness out here. And so always have a hat and a blanket available. And then the wildlife. Believe it or not, there's wildlife around here. Not just the big things like the bears and the cats and the wildebeests and things like that. Mosquitoes. They love pigging out on a Saturday night when everyone's up here with no bug spray on. So you definitely want to bring bug spray. And if you're doing anything walking around in the grass or in the low brush, you're going to want to check yourself for ticks afterwards. So the proper clothing and preparation, we touched on it a little bit. Check the weather forecast. Yeah, that that would have been good for tonight. Now, one of the things that we have on the UACNJ website is a link to the clear sky clock. And what that does, in addition to letting you know how warm it's going to be or how cold it's going to be, it'll let you know what the cloud cover is supposed to be and the quality of the air. Just because there's no clouds doesn't mean that it's good for viewing, especially if you're doing any kind of astrophotography or things like that. If it's really humid, you're going to be looking through lots of water vapor in the air, and it's not as clear, and so you don't see as well, even though it's dark out and clear out. Wind also can stir the air up and make things a little bit less than optimal. And then if there's smoke from fires, we've had that before up here. Any kind of other atmospherical hazards. The clear sky clock gets updated every hour, and you can click on any of the boxes. I cut the key out because I needed to fit the graphic on the screen, but it'll tell you the cloud cover, the quality of the air, and general how good the seeing is going to be on a scale of 1 to 5. And anything that's a 2 or less, just not really going to be a good time to go looking at stars in the sky. Dressing in layers, bug spray, boots, sturdy shoes. You don't want to be running around out here in sandals or flip-flops. You can step on things. They come off very, very easily. Lots of boulders that are just a little bit exposed, and when you kick them, they don't move. Um, and it's easy to slip off them as well because there are rocks and there's wet grass, and not everything is the nice gravel path. So you want to come out and scout the location in the daylight if you can, especially if you're going someplace new. One of the other things that you need to do as well is make sure you have permission to be there. Um, there's lots of places that look great, but they're somebody's land and they might not take kindly to people just being out running around. So make sure you have permission. You have to consider your equipment transportation. You're bringing telescopes, and if you've got to carry them a mile, it's not going to be too much fun. So you want to know how close you can get so you don't have to carry stuff as far. Up here, you can park and put stuff up in the field here next to the house, and you don't have to carry stuff too far. It's great. Restrooms. If you're out in the middle of nowhere, you got to know where to go when it's time to go. Here we have the porta potty, but there are places that are not as well prepared. So that's something you'd have to figure out before you go. You want to have your red light flashlight. Dew shields. They are for your telescopes because as the air gets cooler, the dew will start forming on your telescope and it will get inside your telescope and it'll do bad things to your telescope. You don't want to have that happen. And check the cell service where you're going to be, because if something does happen and you need to make a call for help, it's not going to do very good if your cell phone isn't ready. So, safe observation practices. Never look directly at the sun. All right, say it along with me. Never look directly at the sun. There are tools that you can use for looking at the sun and seeing what's going on the sun. They make filters for telescopes that you can use that are supposedly pretty effective, but if you've ever done the thing with magnifying glasses and ants, well, you're doing the same thing to your eyeball. No matter how nice of a filter is in there, there's still a lot of energy coming out of the sun, going into that telescope, getting focused down into a really fine point. And it's just easier for me. I like to project it instead of looking directly at it. You can use binoculars, and you can just hold them up and get the light to come through the binoculars and project it out on a screen. And that's safe. You can do that. You can see the surface of the sun. You'll see sunspots. You don't need to do it for stars or the moon. Although if you do look at a full moon, it is pretty bright, and it'll hurt your eyes for a little bit, especially if you need to go try and look for other things in the dark. It'll ruin your night vision for a while. You can use star charts to pre-select your targets. We have planispheres and star charts that are available here. They are available online. You can see what's going to be up in the night sky if there's no clouds and get an idea of what you're going to do. Is there going to be a moon to make the sky less dark? Is there going to be no moon so that you don't get that extra light to help see? Dressing appropriately, of course. Using binoculars or sighting scopes to find your targets. And that'll keep you from having to swing your telescope around wildly looking for things and being in a really, really awkward position sometimes trying to find things. And making sure that someone knows where you are. If you're going out by yourself, make sure someone knows where you are. That way they know where to start looking for you after the bear gets you. Bears don't get you here. It's okay. Yet. There's always a first time. And, of course, using specialized tools for solar observation. When the eclipse comes, and we'll talk about eclipses later, the last one that came in 2017, we had a huge crowd up here, even though it wasn't a total eclipse. There's another one coming in 2024 that's going to be almost total. It's been about 92% or so. So you'll only have to go as far as Syracuse or Buffalo. You'll be able to see Cleveland, Niagara Falls. I think Niagara Falls is already booked out because it's going to be right in the path of totality. And who doesn't want to get that shot of an eclipse right over the falls? You probably won't even be able to move a boat around there for a week beforehand. And if you're going to be using any kind of electronics in your observing, some people will have AC powered or battery powered telescope mounts with the that'll automatically move things. You want to make sure your cables are secured so that people aren't stumbling around in the dark and tripping over your cables and wrecking everything. Up next is light pollution. We don't have to worry too much about light pollution tonight because we have clouds. But this is a map of the light pollution around our area. And we are right here on the edge of the orange and yellow. On this map, white means don't even bother. Red means don't even bother. Orange means you can try. You'll see a couple things maybe. Yellow is not too bad, but you're not going to find anything better in New Jersey. And as you get closer to the greens are okay. The blues are really good. The dark gray and the black are super. As you can see, there's not very many places that are blue or black that don't involve going offshore about 100 miles or up into the mountains. There is a place in central Pennsylvania. I know a lot of our members here make trips out there. It's dark. It's remote. Cell phones don't work. But they get some great pictures when they do out there. So light pollution is caused by artificial light. That's street lights, car lights, house lights, any kind of light that's outside. Most of it is bad, but people like to see in the dark. It's really only something that's affected us the last 150 years or so, and just getting worse as people spread out. Light pollution washes out the fainter objects in the sky, so you're only going to see the bright stuff. You're not going to be able to see very many satellite passes. You won't see the Milky Way. You won't see a lot of the dimmer stars. So some of the things you can do are going out to the darkest sky sites you can find, waiting later into the night. So hopefully some people have turned some exterior lights off. Helps a little bit, not too much. You can wait for a big power outage to take out New York City. It's really nice up here when the power goes out. You can see a lot because this map goes from all whites and reds and oranges to all nice blues and blacks. And one of the things you can do as a troop project, if you're looking for like an Eagle Scout project, is you can work with local astronomy clubs who do presentations to town boards and county boards about light pollution and things that can be done. Changing out lights for different color lights instead of having the really harsh bright lights. They're a softer light that doesn't reflect as much, and they're more of a yellow instead of a blue. You still need light, but you can do something to make it not so horrible. So astronomical, wow, words. Astronomical tools and instruments. What is the cheapest thing you can use to look at the night sky? Your eyes. You don't need to have any kind of specialized equipment to enjoy the night sky. All you need is a sky without clouds. And apparently that is too much to ask sometimes. Yes, 10 minutes or more, depending on how good your eyes are. It can take people my age about half an hour, if they ever get adjusted at all. It's you don't see anything. You don't see stars. Don't get old. So with your naked eye, you can see the entire sky when there's no clouds. And you can also cheat and use phone apps. There's Sky Map, and there's some other services that you can get their apps, and you can point them out at the sky, and they'll tell you exactly what you're seeing. So you can see almost everything. You don't get really good close-up details of stuff, but you can see what's there. And for a lot of the merit badge requirements, naked eye is really all you need. And then you can move up to binoculars. Binoculars are more portable than telescopes because they're smaller, they're easy to carry. You see a wider section of the sky with binoculars. And when you're actually looking at the sky, the images come into your eye right side up. And you can use your binoculars to help find targets for your telescope. Telescopes. Why we're all here in the buildings over there. We have some older ones inside in the museum. You see a greater detail of a small section of the sky using a telescope. You can see the moons of Jupiter with even a very small telescope. You can see the rings of Saturn with not too big of a telescope. You can see lots of detail on the moon. Telescopes have larger apertures, the openings, so they gather more light, and that lets you see dimmer objects. you can attach a camera to a telescope, and that lets you take pictures. It used to be just film cameras, and now you can use digital cameras as well. And all the pictures that you see coming from the Hubble telescope are not on film, they're all digital. And the ones that you saw from the new James Webb telescope. Anyone see the press conference on Tuesday when they revealed the first 5 pictures? The background I'm using is one of the pictures. Telescopes can also see more than just what our eyes see. You can use attachments and see infrared, and you can see ultraviolet. That's what they use on the space telescopes so that you can see a little bit better. But they do have those kinds of attachments available for cameras and telescopes here that let you see those wavelengths. They're not as good because to be really, really good, they have to be super cooled. And we don't have a liquid nitrogen vat around here. I think we should put that on the list. You have to keep them super cool, and that's just something for bigger telescopes at universities and public places. So there are different types of telescopes. The first one is the simplest one. Any of you kids in the back know which kind of telescope this is? Anyone? You can just shout it out. You don't need to raise your hand or anything. Yes, this is a refractor. And it's called a refractor because it refracts the light from a lens in the front of the tube and into a smaller lens at the using the eyepiece. And it's pretty simple. This was the first telescopes back in the 1600s, were just 2 lenses in a tube, and you actually focused them by moving the whole tube. The other type is the reflector, and they're called reflectors because they reflect light. So instead of coming through a mirror at the front or a lens at the front, they're hitting a mirror in the back that focuses the light down to a mirror in the middle and then out through the eyepiece, which has another lens in it that lets you look at whatever you're looking at. So there's pros and cons. Refractors are very, very easy to use. You can buy one at Walmart for pretty cheap. Take it out of the box, put it on the mount. The mount's cheap. It's going to break after about a week. But that's it. You put it up, you point it at what you want to look at. It's working. It's great. Super easy. They're portable. They're light because there's really not much to them. They don't require much maintenance. You just keep them dry and warm and cool, and that warm and cool at the same time. It's you want to just take decent care of them. Don't drag them through the mud. Don't use them to hit your brother or anything. And you get good performance for them relative to the price. So they're a very good starter scope if you're going out to look for something. But they do have some cons. They are blurry around the edges, especially in the cheaper ones. The optics aren't super high grade because they're cheap. You're paying for good optics. And so they get a little blurry around the edges, but it's not really anything that's going to affect you when you're first starting out. You need time for them to adjust to the temperature because they've got that big tube. It's going to be different temperature inside the tube when you've got it stored in the car or stored in the house. You take it out, especially in the winter when it's cold out. You got warm air in the tube and cold air outside, and it needs time to adjust so that you get your best pictures and your best vision. And the other big thing with refractors is because the lens is up here and the eyepiece is down here, you're doing all sorts of weird things to try and be able to see through that eyepiece. You're bending over, you're hunched over, you're laying on your back. Just not always very comfortable. It's not easy to get a good setup with a refractor. So reflectors, the pros to a reflector are that they have the best aperture to price ratio. So you can get a big refractor. We have 8s, 12s, 14s, and 16s here, I think. Yeah, we got a lot of them. And you'll if and it looks like there's actually some sun coming out over there. So if they do open up some of the observatories, you can see the different sizes that people have. Because you have that wider aperture, you get a wider field of view. You can see a little bit more in those telescopes. The imaging on those is super crisp because the light's just being reflected. It's not being refracted except at the eyepiece. And reflectors do have some big cons to them. They are, or can be, very big, very heavy, and not very pleasant to store. And if you've got to lug one of those things around, you don't want to lug it around too long, because one of the other problems that it's going to have is collimation. Collimation means aligning the mirrors. If your mirrors aren't aligned correctly, you're not going to see anything. And driving it around, bumping it around while you're carrying it, just every day-to-day life is going to cause those mirrors to come out of alignment, so you have to collimate a lot. The first time you collimate a telescope, it's horrible. It takes a long time. There are lots of videos to show you how to do it for specific brands, and it's great because those people have done it a lot. They know exactly what they're doing, and they do it really quick. The first time I tried collimating my reflector, it took me about 45 minutes, and now I can do it in about half an hour. Most people that have been doing it a lot can do it a lot quicker, but it's still something that you have to worry about every time. There's a third type of telescope that I'm not going to talk about. It's called the catadioptric. It kind of combines the best reflectors and the best of reflectors. It also combines some of the worst of refractors and reflectors. It needs to be collimated, but it is light and it's expensive. But they are really nice. But there are other types of telescopes that you need to know about for your merit badge. And one of them has to not use visible light. So refractors and reflectors don't work. You have radio telescopes. So this image, who can tell me what that is? Just go ahead and shout it out. There's this one right here. Anyone see the movie Contact? If you haven't seen Contact, why not? It's a great movie. Go ahead. This is called, it's got a really, really tough name. It's the Very Large Array. This is out in the desert in New Mexico. There are 28 total radioscopes, 27 of them in use at any time. They are on rails, and they're set up in a Y pattern. The rails are 7 miles long. So the telescopes, the individual scopes, can be anywhere from 2/3 of a mile, with all 9 of them on that arm, up to 7 miles away. So you can have a 21-mile diameter telescope. Each one of those is an 82-foot dish, weighs about 230 tons, and it has 8 receivers. And they can all be pointed individually. They have alt-azimuth mounts, so they can spin both horizontally and vertically. And they can point at pretty much anything in the sky. There's been about 5,000 astronomers have used it since it came online in 1980. 14,000 different observational experiments have taken place there, and 500 astronomers have earned their PhDs using the Very Large Array. It used to be open to the public up before the pandemic. Now it's still closed. You can't go out and visit it anymore, but you used to be able to. If you are working on a qualified project, you can request time there as well. And on the right, space-based telescopes. Of course, the Webb telescope is the big news this week. It's finally online after it was launched back on Christmas of 2021. It has 18 mirrors that point at a central mirror. It was before this one. Hubble was the main space telescope. That was launched back in the 90s. It needed a repair mission before we could actually use it. And ever since that repair mission, it has been just absolutely dazzling us with some of the pictures that it's sent back. Hubble has an 8-meter mirror on it. It's about the size of a school bus. The Webb, the mirror is twice as wide. It can see all the way back to the beginnings of the universe. I've got a picture later that they put out that shows you just how powerful it is. There are instruments, and this is one of the other requirements for the merit badge, is that you're going to be talking about some of the instruments that you can attach to telescopes. And cameras is the first one. There's different CCDs, charge-coupled devices that you can use that can get either visible light or infrared or ultraviolet. They're a little bit expensive, but the camera in your cell phone is a CCD, just not a really great one compared to some of the ones that are used for astronomy. Depending on who's setting up tonight, we have a lot of photographers here, and feel free to ask them about their setup and what they've done and some of the pictures they've taken. We've got them inside on the walls, and they're also available on our website as well. You can see images taken from here by people that volunteer at Jenny Jump from telescopes here at Jenny Jump. Spectrographs are things that will break light into its component pieces. And by doing that, you can see the temperature of a star, you can see the density of a star, and you can see what the composition of that star is, just by looking at the different frequencies of light that are coming through it. And they've also used that to look at exoplanets. One of the pictures from the Webb scope that came out this week was a spectrograph look at an exoplanet that was orbiting a star, and they could actually find water vapor in the atmosphere based on the light that was coming through the atmosphere of that planet as it orbited the star. And then there's photometers, and a photometer just measures the brightness of a star, and that is one of the main things that's used to discover exoplanets. You're looking at a star, and you could say it's a brightness of, we'll just say 10, and then the next day it's a 9.9, and the next day it's a 9.7, and then it's back to a 9.9 and back to a 10. What happened to that star? A week later, the same pattern happens. So it's something that's blocking the light from that star, probably a planet. And by having good sensitive photometers, you can look at stars. The disadvantage to that is that it has to be edge on to us. If you're looking at top down, you're not going to see the light change very much in a star. All right, so caring for telescopes, the next section of the merit badge paperwork. It's actually pretty simple to care for your telescopes and your binoculars. Keep them in your case when you're not using them. Keep them cool and dry. Don't store them in wet, flooded basements. That's not good for the optics. And always wear the strap. Don't do like I did when I was my son's age and my dad got $300 binoculars and he let me use them, and I was not wearing the strap and I dropped them and I broke them. I did not get to play with binoculars anymore after that. That's $300 in 1980 money. When you're going to clean the lenses, you can use the air spray, the blowing air that you can use to keep your kid in line. He likes that. And you can use disinfecting cleaner on the eye cups on binoculars, especially if you're going to be sharing them between people, but don't get that on the lenses, just on the cups itself. So for telescopes, it's pretty much the same. You want to use the original boxes. There are people here who have made customized travel cases with really nice hard foam and perfectly laser cut cutouts to hold everything. If we actually get to look at stuff tonight, and it looks like it might be breaking up a little bit, but we'll see. If they break out the eyepieces, you'll see that they come in their own carrying case with a couple dozen eyepieces in them, each of them with their own cutout. Just like a toolbox for a handyman, you want to keep everything where it belongs and not lose them, because eyepieces are expensive. You want to make sure that your scopes stay dry and clean, and you want to make sure the boxes stay dry and clean. If you put the box out and leave it open and it starts getting cold or cooler and dew forms inside your box and you put your telescope in it, it's not going to be good. Don't take things out of the box till you're ready to use them, and of course put them back in the box when you're done using them. You can ask my wife, I'm not very good at that. And don't wipe the optics on your telescope. Use the canned air. Scratched lenses are not good. All right, stars and constellations, the stuff that everyone really wants to know and hopefully we get to see later. The merit badge program requirements are that you need to be able to identify 10 constellations, and 4 of them have to be in the zodiac. Now, Hopefully we'll see a couple of them tonight. But I used Stellarium to take a look at what tonight's sky would be. So if you were looking south and the trees weren't all here, so if you just go down a little bit, if you were looking to the southeast, you would see these stars. Might be a little hard for the people in the back to see, but if you want to sneak up a little bit, can anyone tell me anything that's there? No. No. We have Scorpius, yes. So we'll use the software and cheat a little bit. We'll throw the lines and the labels up there. So we have Scorpius would be visible in the southeastern sky with the bright red star Antares, which is the heart of the Scorpion, and it is a zodiac constellation. Next to that is Sagittarius, which is also a zodiac constellation. And looking up more towards the south, you have Altair in the constellation Achaea, the eagle. There are some other big constellations that, if you really want to look at them, look at a site like Constellation Guide or Heavens Above. Lots of different places that you can look on the internet, and they will break down exactly what stars are in a constellation and where to find it. It's good stuff. So now if we look at the southeastern sky, anybody recognize anything in the southeastern, or the northeastern sky, excuse me, northeastern sky? We look going from southeast to looking northeast. There are a couple of them that stand out. Cassiopeia, the queen. Cygnus, the swan, with the bright star Deneb, which is part of the summer triangle. We'll talk about that in a little bit. This is at 9:30 tonight, so some of the constellations are just starting to rise, like Pegasus and Andromeda. And you have Cephas the king. And now if we look towards the northwest, you'd still see some sunlight at 9:30, still kind of a little bit glary. But anyone see anything on here that kind of stands out? Now, you don't see the whole thing, but you might recognize it. Anyone want to shout it out? You can. It's okay. Don't need to raise your hands here. So you have the Big Dipper, which is not a constellation. The Big Dipper is an asterism. It's part of Ursa Major, which is the actual constellation. You have Polaris, the pole star. And hiding down here behind the tree is Leo, the lion. We have lots of trees to mimic what you see on the screen. So things in the northwestern sky are a little bit tougher to see here because of the trees. But we'll bring out some of the lines. And we'll go back and we'll look at the southwestern sky, which would be this way, which you can actually see pretty well if you're down there. And one of the bright stars you're going to see is Spica in the constellation Virgo, also part of the zodiac. You have Corvus the crow, you have Libra the scales, and all the way up top, kind of hiding up there, is the brightest star in the sky tonight, Arcturus. It's not the brightest star. There are brighter stars. It's just that's the brightest one that's in the sky tonight. And then, if we look straight up, I'm actually not going to give you the answers to this. Hopefully it clears up. Is Vega, which is one of the other brightest stars in the sky. So hopefully you'll be able to get a chance to look at those later tonight. That was going to be homework, but we'll see. One of the requirements on the merit badge is to be able to identify the Big Dipper and follow its position in the sky over time. So this is zoomed out a little bit, looking due north at 9:30 tonight. You would see the Big Dipper kind of straight up and down at 9 o'clock on the clock, pointing at Polaris. Cassiopeia is down here. And stars in the northern part of the sky all circle around this way, and the ones that are closest to Polaris never set. They're called circumpolar stars. So they're always up at all times of the year. So if we fast forward about 3 hours, if anyone's going to be here till 12:30 in the morning, you'll see that the Big Dipper has moved. And so one of the parts of your merit badge worksheet will be talking about why that moves. It's because the Earth spins. And you see Cassiopeia has also moved. All these stars have moved a little bit. And so during the summer, because the nights are not too long, it'll get about a third of the way across the sky. And as sun rises, it'll be down at about here. Different times of the year, it'll be at different positions at the same time at night. So if you were to look in the spring, it would be on the other side. And in the winter, it'll be more towards the top. One of the other things that we would hope to be able to see tonight, and this is looking at 10:30 and looking southeast, is we would be able to see the Milky Way, our galaxy, looking right towards the center of it. The center is right around here where it's bright. What you're seeing is a lot of glowing gas and dust. There's not really too many stars that you see because they're so be dying. There we go. It's back. Also, we'll have Saturn rising at about 10:30 tonight in the southeastern sky. If we jump forward another hour, the moon comes up. Who knows what phase the moon is in now? Go ahead, chat it out. Anyone else? This is the waning gibbous phase. So it was just full on Wednesday, so it's moving towards its third quarter, where third quarter really is half the moon that we can see. The other half is lit up, but we can't see it. It'll be a crescent moon in about a week and a half, and then another week or so after that. It'll go to waxing crescent, and then new moon, and then waning crescent. And if you stay till 12:30, Jupiter will be up. Go ahead. It won't be a full moon. We had the full moon on Wednesday. So now it's come back in. Okay. Okay. I'm being nice to the camera. So that's what you would see if you were still here at 12:30 tonight, or 12:30 tomorrow morning, as it were. You'd also see the constellations have moved a little bit. Neptune is also up, but we can't see it because it's just very dark. And also Vesta, one of the minor planets, which you can see through a very powerful telescope on a very clear night. Also looking at, this is still 12:30 in the morning, just looking south a little bit. It would be darker, and you might be able to see the Milky Way a little bit better, especially if it clears out. On decent dark, clear nights with no moon, we can see it pretty well here. But if you get out to a dark sky site, it's very very impressive, especially if you can get out someplace out west where there's no lights and no people and just cows for 50 miles. And it's great. You can read a book by it. So we've covered the constellations in tonight's sky, but we did not get all of them. We didn't get the good ones. Who can tell me which two constellations you can see fully here on this picture? Go ahead. I have Orion. What's the other one? Okay. Anyone else want to guess the other constellation? So one of the cool things about Stellarium is that you can actually use the art that was ascribed to some of these constellations and have that show up. So we have Orion the Hunter and Taurus the Bull among some of the other partial constellations. And Orion is very distinctive with the belt, the nebula in the sword, and 4 pretty bright stars. You also have Aldebaran, the bright red star, which is the eye of the bull. As a bonus, Mars is in there as well. This picture would be looking south exactly 6 months from now. So Mars is making a guest appearance, and then up here is a star cluster. Anyone drive a Subaru? You're familiar, you know exactly what this looks like. This is the Subaru logo. They put it in the sky. They paid lots of money for it. This is the Pleiades. And looking at those through binoculars is really, really cool. That's one of the things where binoculars are perfect for looking at those. You can also, with a good telescope, you can see the nebulas in Orion's belt and in the sword. Those are really cool to look at. I believe we have some pictures of those on the website, and some of our members, if we are, it looks like they're doing a little bit out there. They would be glad to show you some of the pictures. All right, we're going to do this again. We're going to look just a little bit more to the east, same time, exactly 6 months from now, looking a little bit to the east. Anyone recognize any of those constellations? All right. You have Gemini the twins and Cancer the crab. And you also have Canis Minor, the small dog. And down here is Canis Major, the big dog, which has Sirius in it, which we haven't looked at yet. And Orion is still just kind of hanging out there because we haven't turned away from him completely. So Castor and Pollux are the two twin stars in Gemini. And so now one of the other components of the merit badge requirement is being able to list 10 stars that you would see in the sky. And so there's 6 of them in tonight's sky, behind those clouds. I promise they're up there. Altair, magnitude. So the lower the number for magnitude, the brighter it is. And then the distance in light years. So Altair is 17 light years away. The light from Altair left there and is getting here. It left 17 years ago. The light in Vega, which will be almost directly overhead tonight, left 25 years ago. Question? No, that is a picture from the Webb telescope. That's a nebula where stars are 0.05. It is 554 light years away. And Deneb, which is also pretty bright, but not, that's about the 6th brightest star you'll see. It is a big bright star, but it is 1,412 light years away. So light that is leaving, or light that's hitting here today, is what left sometime around when I was born. And if we look to the winter sky, we have 7 bright stars that you'll will qualify on your merit badge paperwork. Aldebaran, the Eye of the Bull, is magnitude 0.85, is 67 light years away. Betelgeuse, which is an absolutely ginormous chunker of a star. If you put Betelgeuse where our sun is, the edge of the star would be out near Jupiter. So we'd be all crispy if we were orbiting Betelgeuse from where we are now. It's 500 light years away, 498, we'll say 500. Capella, 43 light years away. Sirius, the brightest star in the sky, is also one of the bigger stars, and it is only 9 light years away, which helps it be so bright. And has anyone heard the phrase, the dog days of August? Someone? All right, so dog days of August. You know where that comes from? That comes from the ancient Greeks. What happens is right around sunrise, early on in August, so just a couple weeks from now, Sirius rises just as the sun rises. And so the ancient Greek astronomers thought, well, that really big bright star is rising at the same time as the sun, and it gets stupid hot. So obviously that star is helping make it very hot. And Sirius being the dog star, because the dogs, it's so hot that the dogs would just lay around. Because who wants to be out running around in the heat? Nobody. Dogs ain't stupid. So it just became the dog star, and it's dog days of August. And it is used, the rising and setting of Sirius in the sky has been used since ancient times to time things of like when to plant crops, when to harvest crops. It's just, it's that big, you can't miss it in the sky. It's so bright. All right, we're going to go look at the planets real quick. We're going to start powering through the last of this, and hopefully get done with this relatively quickly. If you were here at 4:30 this morning, who's going to be here at 4:30 this morning? Who wants to stay up till 4:30 in the morning? All right, now this is one of the great things about astronomy, especially when you're a kid. I want to stay up all night, and it is for science. Mom, you can't make me go to bed. I'm doing science. Are you against science, Mom? Really? Now, who wants to get up to be up at 4:30 in the morning? Nobody. All right, so at 4:30 in the morning, you'll see 4 of the 5 visible planets, assuming there's no clouds. Saturn will be pretty up high in the southern sky. The moon is still going to be up there. Jupiter, Mars is going to be up. Aldebaran will be coming up. And Venus will be lower in the northeastern sky. So you'll be able to see 4 out of the 5 naked eye planets at 4:30 this morning. So we'll do a quick tour of the planets. Who knows what planet this is? This is Mercury. So what do we know about Mercury? The quick and dirty stuff. It is the smallest planet in the solar system. It's the closest to the sun. Now, is there ice on Mercury? There is ice on Mercury. It was discovered by the people using the Very Large Array, studying radio wave reflections off the surface of Mercury. And in the deepest canyons and craters on Mercury, there is ice. It's there because it's never touched by the sun, so because there's no atmosphere, it's just super cold. When you're in the light on Mercury, it's not very comfortable. But when you're in the dark on Mercury, it's just really uncomfortable the other way. It is super cold. One day on Mercury lasts 59 Earth days, and 1 year on Mercury lasts 88 Earth days. So it goes around a little bit more than 4 times a year. So if you want to use Mercury years, you can tell your parents you're in your 20s now. And then they can tell you to get out and get your own apartment. All right, next. Good. Yes, you sounded so excited. Yes, this is Venus, covered in clouds. Venus is the hottest planet, even though it is not the one closest to the sun. It is so hot because it has that thick layer of clouds, and it rains sulfuric acid. It rotates backwards. So it doesn't rotate west to east like Earth does and most of the other planets. It actually rotates east to west. It has a super dense atmosphere, and 1 day on Venus lasts 243 days. And for Venus to go around the sun takes 225 days. So it rotates slower than it goes around the sun. So you only get 1 sunrise a year most years. So what would be the next planet? Mars. Well, I mean, Earth would be next, but we don't need a telescope to look at Earth. So we have Mars. Mars has ice caps, it has floods, it has volcanoes, it has canyons. Now, the volcanoes are not active volcanoes, but they are still the largest mountains that have been observed in the solar system. The canyons are the deepest that have been observed in the solar system, and there is evidence that there have been floods. They can look at the pictures taken from some of the orbiters, and you can see the pattern in the sand looks exactly like the patterns in the sand where there have been floods here. There are 2 tiny little captured asteroid moons for Mars. Neither Mercury or Venus have any moons. We have 1. So Mars has 2. It has a very thin atmosphere. Is 24.6 Earth hours, so just a little bit longer than a day. So how many people saw The Martian? A couple hands went up. So you'll know, if you've seen it, you'll notice that they keep track of days. They don't call them days on Mars. They call them sols because they're a little bit longer than a day, but eventually it'll get really off when you're just looking at, well, it was midnight here and midnight there, And now midnight here is 12:30 there, and it just drifts, so they keep track of it with sols. All right, who wants to take a guess at how long it takes Mars to go around the sun? Let's go ahead and shout it out. 336 is one of the guesses. 60, 360. All right, 1 year on Mars is 687 Earth days. So almost 2 full years. So that means that the seasons on Mars last twice as long, too. 6 months for a winter instead of the 3 months here. 6 months for what would pass as a summer there. All right, next up, Jupiter. Jupiter is a gas giant. It is the largest planet, and it has 79 confirmed moons that we've been able to count. Looking through a telescope, you can actually see 4 of them on any given night, unless one of them is behind the planet. If it's in front of the planet, you can actually see the shadow of the moon on the planet. And that's what we see here, is the shadow of one of the moons. It has a very thick atmosphere, and it has a very dense core of metal hydrogen. And one of the cool things that happens on Jupiter is that it rains diamonds. So yeah, get those spaceships ready. 1 day on Jupiter is 10 hours, and it takes 11.8 years for Jupiter to go around the sun. So how many people are less than 11? You haven't been around for a whole year on Jupiter yet. Everyone knows what this one is, right? Saturn, with the rings, the most distinctive feature. It's also a gas giant. There are 53 confirmed moons. They think there's another 29, but they haven't been able to really lock those in yet. So they're staying at 53. It has the very thick atmosphere as well. 1 day is 10.7 Earth hours, and 1 year is 29 years. Now, there are theories that way back in the beginning of the solar system, Jupiter and Saturn were actually a lot closer to the sun, right about where Earth is now. And it was just over time, they drifted out. Now, there are other planets that you can't see without a telescope, although Uranus, on a really, really, really clear night in a really, really, really dark sky with really, really, really good eyes, you can see it if you know exactly where to look. You're not going to have that happen here. But you can see it through a telescope. It does not look very impressive through even the biggest telescopes because it's just a pale green disk. So we're not going to worry about that because that is not part of the merit badge. One of the things that is on the merit badge, though, is the moon. And one of your assignments in the workbook is that you have to be able to draw a sketch of the moon with listing out 5 of the craters and 5 of the seas. So we have lots of seas listed here, but only 3 craters. So if you go to nasa.gov, moon.nasa.gov, you can get a lot more pictures and diagrams and listings of what you can see. This is almost a full moon. And one of the things about the full moon, you think we can only see 50% of the moon, but because of some variation in the way that it revolves, we can actually see about 58% over time. We see a little bit on the edges. And then one of the other things that you have to discuss for the merit badge is orbits. And orbits is just something that's falling towards the thing that's pulling it in via gravity. In this case, the moon is falling towards the Earth. Gravity is always pulling the moon, but the moon is moving so fast that it's missing the Earth. It's the same thing for satellites, for the space station. The space station is constantly falling towards the Earth. It's just going so fast that it gets past the edge of the Earth, and it just keeps falling. So you're constantly falling, and that's why it's microgravity, because you're falling at the same rate as everything around you. So there is still gravity. It's just not really affecting you. On the merit badge, you'll need to be able to discuss how the moon moves through the sky over the course of a few days. So this would be, if you were looking at 4:30 this morning, the moon is blown up in the software here just to make it a little bit easier to see, because the moon is not really that big in the sky. The moon is about the size of your thumb held at arm's length. And so if we kept it at normal scale here, it would look just like a dot. So blown up, the moon is above the horizon in the southern sky, very near Saturn, and that was this morning. So if we fast forward to 4:30 this tomorrow, it's going to have moved. It's now about halfway between Jupiter and Saturn. And if you notice, Jupiter and Saturn actually moved a little bit as well. And if we go to Monday morning, the moon has moved more. It's closer to Jupiter now and higher in the sky. And if we go Tuesday, also at 4:30, it's now past Jupiter. And Jupiter and Saturn continue to drift a little bit towards the west. And you can see that the phase of the moon is changing. And on Wednesday morning, it'll be a quarter moon, the third quarter. And it'll be higher in the sky and further towards the southeast. And so that's one of your merit badge assignments on the worksheet, is to be able to sketch that out. So the phases of the moon. Who knows what causes the phases of the moon? Besides you in the NASA shirt, who knows everything, because that's what I taught you. Go ahead. What's the phases of the moon? Very good. So it starts out as a new moon, where the moon is between us and the sun. So we don't see any of the light reflected off the moon because it's in the shadow towards us. As it starts moving around, it becomes the waxing crescent. So the easiest way to remember this, if you've seen Karate Kid, wax on. Wax means growing. Waxing is growing. And it goes from the waxing crescent to the first quarter, to the waxing gibbous, to the full moon. And then the opposite happens on the way down. Waning gibbous, third quarter, waning crescent, back to new moon. And it's all caused by the way the moon orbits Earth and the angle of the moon and the Earth and the sun. So one orbit for the moon takes 29.5 days, which is about a month. Moon month. How'd that happen? One lunar rotation is also about 29.5 days, which is why we always see the same side of the moon. There is no real dark side of the moon. All sides of the moon get lit up as it goes around the Earth. We just don't see one side, so it's more accurate to call it the far side of the moon. The pictures we're seeing here are for the northern hemisphere. It's on the right-hand side when it's growing, left-hand side when it's shrinking. If you were in Australia, it would be the exact opposite. It would be growing on the left and shrinking on the right. And the moon is not at a constant distance from us. We'll usually say it's about 240,000 miles because that's the average, but orbits are not perfect circles. Orbits are ellipses. And so there is a point where it's closer to us and a point where it is further away. And you can see that with full moons. When it's closest to us, and everyone goes crazy because it's the supermoon, and it only happens once in a lifetime. That happens quite a lot. Supermoons are 14% bigger and 30% brighter in the sky because the moon is closer to us. And when it's farther away, when it gets to full moon, it's not as big and not as bright. And that also will affect eclipses. And that's our next slide. It's almost like I planned that. So eclipses. We had in 2017, we had the Great American Eclipse, which started just off the shore, off of Oregon, and came all the way across the country and went offshore in South Carolina. And so this line is the path of totality. Anyone that was inside of that got to see the sun completely eclipsed. Anyone outside that line, as far away as New Jersey, you would see still quite a bit because the moon's shadow is pretty big, but the totality shadow is not very big. In 2021, there was an annular eclipse that came up over the pole starting in Canada. So they put that on the map. In 2023, there will be another annular eclipse. So annular eclipses happen because the moon is farther. And so an annular eclipse is going to happen in October of 2023, coming onshore in Oregon and going offshore in Texas. And then in 2024, we get another total eclipse. And that's the one that's going to be pretty close to us. We're going to be about 92% total. But you just have to drive a few hours to get into the path of totality. And if you have the chance to do it, it's really recommended you go out and see it because these don't happen very often, and they are really worth it. We went out in 2017. We went to Wyoming to see it because it's normally not cloudy on the August day that we were out there. Now, you can't predict the weather that far in advance. You can just go by trends. And so 95% of the time over the last 20 years, it was clear in Wyoming on the days that we were going to be out there. So we rolled the dice as opposed to going to South Carolina where it was cloudy 2/3 of the time. And so there were lots of people who didn't really get to see it directly because the clouds were in the way. So in 2024, in April, it'll start down in Mexico, come up through Texas. Carbondale, Illinois is right in the middle of both of them. So they get a 2-for-1 if you live there. And it comes up over Indiana, Ohio, and over Lake Erie, Lake Ontario. Toronto is just outside of totality, but Montreal is inside totality. Montreal is really nice in the summer. And of course, if you're looking at an eclipse, you're not going to look directly at the sun without good eclipse glasses. They have really, really strong filtration on them that you can use them, and you can look at the sun if you're wearing them. You still don't want to look too long. Once the total eclipse happens, then you can look at that because it's not as bright. It's not going to damage your eyes. You just have to be careful because as soon as it becomes not a total eclipse, it will start burning your eyeballs out. So how do eclipses happen? Oh, next slide. So this is just a close-up of where it's going to be for Buffalo, Cleveland, Syracuse, Montreal. So plan your trips accordingly. All right, now, how do eclipses happen? We get a full moon or a new moon every month, right? So why don't we get a solar eclipse every month? But we need a new moon. So that is how it works. You get a new moon. There is actually an eclipse every new moon. It's just most of the time the shadow is not pointing at Earth. So eclipses form because the moon is 400 times larger than the sun in the sky, and it is 400 times closer. It's just one of those things that it lines up nice, and that's how we can get total eclipses. Now, because the sun is so huge, light comes around the moon, and it also forms a cone behind the moon. And that's why the path of totality is so small, because you're just getting this little bit of a cone that is coming across the surface. So what happens is the moon, let me go back here. The moon's orbital plane is not the same as the Earth's tilt. The Earth is tilted about 23 degrees from the sun. The moon is tilted about 5 degrees, and that 5 degrees is enough to cause the shadow of the moon as it passes between the Earth and the sun to not actually hit the Earth. So if you were in space, if you had a spaceship, you could go and see an eclipse every month if you knew where to get to. And eclipses are very, very predictable. There's a website, several websites that have the records of them going back into several thousand years BC and up to about the year 5000 CE. So 3,000 years from now, they know when there's going to be eclipses. And one of the famous eclipse stories is from when Christopher Columbus was in Jamaica in the 1400s. He had an almanac because even back then, using quills and parchment, they could figure out when there were going to be eclipses. And so Columbus's crew was kind of stranded on the island, and they weren't getting along very well with the natives there. And it got so bad that Christopher Columbus looked at his almanac and said, hey, we're going to have an eclipse. So he set up a meeting with the king of the local tribe there and told them that you guys are not making me happy, and my God is going to eat the sun if you don't start making things right. And sure enough, the eclipse happened. The sun started going dark, and the natives there completely freaked out because they didn't know that this was all planned and predicted and everything. The sun was getting eaten up by something in the sky. And they came running with all sorts of provisions to Columbus. And so he survived and got away just because he knew a little bit of science. And that plot line has been used several times in other movies going forwards, where people have predicted an eclipse and used that prediction to get what they wanted. All right, so lunar eclipses. Lunar eclipse is when the Earth gets between the sun and the moon. And that only happens at full moons. Now, because the Earth is bigger than the moon by quite a bit, and the moon is not that far away, the whole moon can get eclipsed. But the moon does not go dark during eclipse because there is still light that is coming through Earth's atmosphere, and the red light makes it to the moon, so the moon turns blood red. But again, the same thing happens because the moon and the moon is not aligned going around the Earth directly between the sun. So it takes a little bit more than what happens for a solar eclipse for things to line up correctly, but they do happen more often. All right, so we're almost done here. You have to know, for your merit badge, you have to know about the sun. And this is what the sun looks like if you were able to cut out a chunk of the corner. You have the core, the radiative zone, the convection zone. You have subsurface flows. Now, the sun is 74% hydrogen, and it's 25% helium. So that's about 99%. The sun works by a process called fusion. So hydrogen gets compressed together. Hydrogen atoms get compressed into helium atoms, and it releases a lot of energy. And it takes 620 million metric tons per second. So that's a lot getting converted. And so eventually, over the next 2 billion years, the sun will be more and more helium and less hydrogen, and it'll start to expand. Now, there are 1.7% of the sun that's not hydrogen and helium. It's iron, nickel, oxygen, nitrogen, carbon, all that other good stuff. And you'd think that 1.7% is really not that much, but if you were able to gather it all out, you would have 5,628 times the mass of the Earth. So now our sun is a second-generation star. It's not original from the beginning of the universe. It's the second or possibly even the third time. It's a remnant of a previous supernova that was in a nebula. And the theory is that there was another star that went supernova and caused all the dust and gas and everything that was in our nebula to contract a little bit with the shock wave that went through. And it would start spinning and coming together, and it formed the disk that eventually became our solar system. It's 10,000 degrees Fahrenheit on the surface of the sun, which is probably too cold for some people. And one of the things about the sun is the energy that it puts out. And so if you've done any work with solar panels, one of the things you'll know is that the solar constant is 1.37 kilowatts per square meter. That's the amount of energy coming from the sun hitting the surface of the earth constantly. 1 second of sunlight produces enough energy that it could light all the light bulbs that we need for a year. And then there are sunspots on the sun. Sunspots can be the size of the Earth. So they may look tiny when you're looking at them safely by projecting the sun onto a surface, because you're not looking directly at the sun, right? So these are cool spots on the surface of the sun, about 6,000 degrees. They're caused by variations in the magnetic field around the sun. The sun does not rotate at a constant speed. The center, the big fat part of the sun, goes a lot faster than the area around the poles. And that can really twist and distort the magnetic field. And eventually, some of those things kind of just snap, and that's what causes sunspots. Sunspots can spawn solar flares, and if you've ever looked at some of the videos that they've released from SOHO, the Solar Observatory, they are really, really cool looking. And then there's coronal mass ejections. Those are also cool looking, but you don't want to be in the path of that. If you really want some nightmare fuel, Google the Carrington event. It happened in 1859. There was a coronal mass ejection that came from the sun and made a direct hit on the Earth. And when that happened, the Northern Lights, which we don't even really get to see them except for maybe once or twice every couple of years, you could see the Northern Lights really, really well as far south as Cuba. The Southern Lights you could see well up into South America. The energy hitting the atmosphere was incredible. It fried everything electronic. Luckily, it was 1859, so the only thing that was electronic back then were some street lights and some telegraph lines. The energy was so strong that even after the power sources were destroyed, people could use the telegraphs because of the energy that was still flowing through the lines. If they weren't getting electrocuted when they were using their telegraph, if something like that were to happen today, it would not be a fun time. Just a coronal mass ejection, a big chunk of solar matter launched off the sun and hit us. And these things happen all the time. In 1988 or 89, there was a not very big one hit in Quebec, and that's what caused the big power outage back then, because it fried it overloaded the circuits up there, and so it took out a lot of the eastern power grid. And that was not a very big one. If something were to happen like that, for the space station, they would have to get everybody off and back before it hit, because the radiation and the energy that would hit, you'd cook your astronauts. So anybody that's not protected would have a bad day. And that's one of the things that they have to look at when they're planning for moon colonies or Mars colonies, is if something like this were to happen, you need a place to be able to hide. It's going to happen. Eventually, it will happen to us.
We will be having a Q&A session at the end.
Yeah, so it's not a matter of if, it's a matter of when, because it happens quite a bit. It's just that we're a very small moving target, so it takes a lot of bad luck for it to hit us. But that's something to look at. It's when you read some of the news accounts from the time, even back then, it was pretty terrifying. Today, it would knock out anything electronic, GPS, uh, anything electronic. Our power grid would be gone. Transformers would be, if they're not shut down and protected in time, they would be melted. And then you'd have to make new transformers and get them shipped from wherever they're being made, which is not America. And of course, you can't use GPS to navigate the oceans, and you can't use electronics to unload the ships, and they're heavy. So it would take a long time to recover from that. So there's different types of stars, and we're not going to get too deep into this one. This is the Hertzsprung-Russell diagram, and you have the main sequence of stars, which is where most stars fall in. Our sun is decidedly average. There's nothing really special about it. It's medium brightness, medium size. It's not like the big stars like Betelgeuse, the red giants. It's not like the white giants, and it is not a white dwarf. And on that diagram, red's cooler and blue is hotter. The last thing on the sheet that we're going to cover is careers in astronomy. There are about, and this is from the American Astronomical Association, about 6,000 professional astronomers in America. There's about 150 job openings a year and about 125 people that get their PhDs every year. So getting a job directly in astronomy it's not easy. You're going to be doing a lot of research work, but skills that you gain from doing astronomy are very transferable to other sciences. I have a presentation I've done here before called Astronomy, the Gateway Science, because things that you learn in astronomy carry over into a bunch of other scientific fields. But some of the things that you could do, you become a planetarium director, giving shows at planetariums. We have a couple of them near us. You can be an exobiologist looking for life on other planets. Or you could be a data analyst, and that's another one of those skills because an astronomer spends about 20 to 30 nights a year actually looking through telescopes, the professional astronomers. The rest of the time, they are poring over tons and tons and tons and tons of data. And our last thing is going to be the first picture that they brought back from the Webb telescope. This is Webb's first deep field picture. In this picture are over 1,000 galaxies. And you'd think that this is a big chunk of sky, but if you were to take a piece of sand and put it on your fingertip and hold it out at arm's length, that would be the amount of sky that's represented by that picture. So.
All right. Thank you, Sean, for a great presentation. All right. So I noticed a lot of you did get here after the start of the presentation. So quick safety briefing. If you need to use the restroom, we got the porta potty that's lit up by the red light to my right, your left. We do have a museum and gift shop area for after the presentation. Unfortunately, I'm doing we're going to do Q&A, so I won't be available until after Q&A. For those of you who are here, I have it's completely clouded out, so unfortunately we won't have any telescopes open for viewing through. However, Paul does have a couple people, and we have observatories where he can take you on a tour and show you the scopes. So we are going to be having a brief Q&A session because I know you're all very anxious to actually get to see some telescopes and whatnot. And I just ask that the people here, when you raise your hand to ask a question, just wait till I get out to you and hand you the mic, because if you have a question, chances are the people online have a question. So with that, I'm going to start us out with an online question, and very simple one. You mentioned this is based on the merit badge from the Boy Scouts. Are can this be used for uh, badges for other scouting groups like the Girl Scouts?
Most of it, yes. You would have to look at their specific requirements, but astronomy is astronomy for the most part. They might have some different specialized requirements, but this presentation will probably get you most of the way for any of the other scouting groups.
Right, and just based on that, if they were looking on acquiring a telescope, what what's a basic type that you would suggest?
There's no easy answer for that. That is something where if you have the ability to come up here and talk to some of our astronomers, you could ask every single one of them what scope you should get, and every single one of them will give you a different answer. It depends on your budget. It depends on your skill level. It depends on how risk averse you are. I bought Sebastian his first telescope when he was 5. I spent about $80 on it. It was a tabletop reflector. It was not a piece of junk. It was good. You could look through it. You could see the moons of Jupiter. You could see the rings of Saturn. I mean, they weren't great to look at, but if he knocked it off the table, I'd be worried about it breaking. Um, Average telescope's going to run you anywhere between $300 and $700, and it's really not the scope that you're paying for as much as it is the mount. The mount is what will really drive the price. You can get a cheap mount, which is what comes with any of like the Walmart or Amazon telescopes. It just goes on there. Some of them might have a drive that you can hook up to a computer, and it'll help point the telescope for you. The bigger and more expensive the mount, the better, but that's also a lot heavier. You'll see some of the mounts that we have in the observatories are actually permanently mounted to the floor with a concrete pedestal because they're not getting moved around.
Right. Was there a question from our online audience? And I just asked that if you have a question, you raise your hand and keep it up until I get to you because I have trouble seeing in the dark. Anyone? Anyone? Oh, do I have a question there? Oh, did you just raise your hand and say no, you don't have a question? Faking me out. Right. Um, the next question is, do you know why the gas giant planets have so much shorter days than the rocky type planets?
They have a lot more energy. They spin a lot faster, and it's just gas. So it's really just wind that is blowing it around, and they have very, very, very tiny metallic cores that spin very fast.
Right. And the last online question that I got for right now, and I just, if you are online, please if you have any last minute questions, get them in now, just because we are going to be ending this shortly, because this did run a little bit long. And the question was, will UACNJ be open for the eclipse in 2024 like it was for the one in 2017? Uh, and the answer to this is we do not know yet. We are a volunteer based organization. So while we would hope that we can, how we do have to be mindful that we do have appropriate volunteer staffing to handle the number of people that would be coming on site. And of course, it is also so weather dependent hobby. So we are beholden to the elements. Were there any last minute questions from our audience here? Bueller. Right. For everyone here, also, please, if we have flashlights, we are pointing them towards the ground because we don't need to needlessly blind people. And when we go to leave, please do use your headlights because we do not like running people over. And with that, since it looks like our questions have dried up, I want to thank you all for coming in. And like I said, if you guys like this, please find us on YouTube, like and subscribe. It does help us keep going. And have a good night.
And come back on a night when I'm not here because there probably won't be any clouds. Thank you, everyone.